Hello guys, this is Project Green over here with the first upgrade to my multitask Arduino platform. Now this is a pretty quick upgrade to do, I must be honest, but I was lucky. All I had to do was go back to my old projects and I found, as you can see over here, let me aim it over there, and I found my robotic stand, which was made originally to hold the ultrasonic distance sensor, as you see right over here. Let me try to close this up, put it a little bit closer for you to see. There you go. Now this robotic stand is basically two servo motors, one over here, which I call the shoulder, and the other one over here on the base over here, which I call the hand. And this allows me to move the distance sensor into any position I want, left, right, up, or down. Well, for the ultrasonic distance sensor, basically all I need is left and right, but for other applications you can use the second motor for up and down. So let's dig into the sketch. For the section of the ultrasonic distance sensor of this Arduino platform, I'm going to use two libraries, both the new ping library, that is to analyze the data collected from the sensor in a more easier way. You don't need to do it through the library, but it's easier to do it through the library. And I'm going to use the DHT library. Now why is that? Because I am going to introduce the measurements of temperature and humidity of the air, to introduce them into the distance calculations, because you know that the sound travels through air and its speed is affected by the temperature and humidity of the air. Sound goes through very medium, but when it goes through air, you have to factor in temperature and humidity for precision calculations. So I already taught you how to deal with the DHT sensor. The ultrasonic distance sensor is not a lot to it. You include the library, and then you initiate the object with three values: the values of the trigger pin, the value of the echo pin, and the maximum distance for your sensor, minus 400 centimeters, as I put right over here, as I defined already the pins. And then after that, all you have to do is use the sensor with the codes. Now let me show you down where I used it on the sketch, which is right here, the distance measurement function. Now I give a short delay. I've seen some videos, some people give some delays, like I give one down here of 1,000 milliseconds or a second, because it helps to stabilize the sensor itself. But I guess I'm not an expert, I can't tell you if that's really important or not. But then all I do is, once I enter the function, I print a message, which is I'm informing that this is the menu for the distance. Then I take the measurements of the temperature and humidity of the air, and then I introduce them to this formula right over here, which is the formula for the speed of sound. Then I divide that value by 10,000 so that I can transfer that value 2 centimeters. And after I have the constant for my speed, for my sound speed, then I retrieve the duration of the sound from the sensor I shouldn't go into how this sensor really works. There's other videos that explain them in detail how it works. But all I'm gonna say is I retrieve the distance, the duration. I mean, the time that was that the sound took to come back, and I divide it by 2, and then multiply it by the sound speed constant, and that will give me the value of the value of the distance. Now I have another distance measurement over here, which is the measurement of the distance without factoring in temperature, without factoring the temperature and humidity, just to see the difference. But obviously, when you factor in those conditions, it is more accurate. The measurement is much more accurate. And that's all. There it is too. Then I print it onto the LCD. I print both values, and I give a small delay so that the sensor can stabilize, and everything repeats, just like you saw. Just like you saw. No, just like you saw on the video. This was a sketch on how I use the ultrasonic distance sensor on my Arduino platform, and how easy it is actually to use it. And it is really very accurate. I mean, it goes below millimeters. You saw in the video, and it is pretty stable. I mean, if you hold the object in place, the measurements will be repeated and constant. It's a very good sensor, very accurate and pretty precise. So I hope you enjoyed the video, and I hope it was helpful. I'll see you next time, and thanks for watching.